Last time we talked about the various, let's call them basic gas laws, where two things were changing, one thing was being held constant. Today, what we're going to do is we're going to combine those together and get what's called the combined gas law. So a quick review of where we've been. These are the basic gas laws, where you have Boyle's law, volume and pressure, don't worry about temperature. Charles' law, volume and temperature, where we ignore pressure, actually we assume that pressure is held constant, and pressure and temperature where volume doesn't change. But what happens if any of those change, or all of those changes, I guess I should say? And that gives us the combined gas law. And what we're going to do with the combined gas law is just simply combine those three other laws. And if you look at them, if you look at the combined gas law, if you ignore, cover up, or pretend that temperature is not there, then what you have is the Boyle's law. If you completely ignore pressure in the combined gas law, then get rid of pressure and you have this thing reducing to Charles' law. And likewise, if volume is erased from the combined gas law, then it becomes the Gay-Lussac law. So the combined gas law is really just a combination of the other three. Also, like two of the other three, temperature must be in Kelvin. Even though you'll be given a temperature in degrees Celsius, you must use temperature in Kelvin. So we're going to dive right into examples because you already know how to do gas law calculations. All that's going to happen now is it becomes a little bit bigger, and you'll recognize a combined gas law question right away because you'll be given more numbers, more information. So here we've got 3.6 liters, 40 degrees Celsius, 85 kilopascals as our first set of conditions, and then we're asked what's the new volume when we change the temperature and change the pressure. Again, I like to write out the information that I have for two reasons. One, it helps me to collect together the first set of conditions with the second set of conditions and make sure that I've got those straight. Second thing, probably a little bit more importantly, is that it gives me the opportunity to write down or correct the temperature, convert the temperature right away, and then I know I won't forget. So taking that information and putting it into the combined gas law. Now, last time we rearranged the equation a couple of times and then put numbers in. This time what I'm going to do is I'm going to put the numbers in and then rearrange for the thing I don't know. Doesn't really matter, you'll get the same spot either way. So I put in the numbers that I have, I put them in the places that they're intended for, and my second volume is still an unknown, I'm still solving for it. In order to solve for second volume, I'm going to have to divide both sides by 325 kilopascals and multiply both sides by 253 Kelvin. And when I do that, of course, volume 2 gets isolated all by itself. And then when I do the full calculation, I end up with a second volume of 0.76 liters. Again, I know it's liters because my first volume was in liters. Second point, I like to carry units all the way through the calculations. You don't need to. I think it's easier when we're doing examples like this for you to see the units. You can track them back a little bit easier. And second thing, but to finish that point, you do need to have a final unit on your final answer. So 0.76 is not enough. 0.76 liters is enough. That's about all I want to say about that one. Carrying on with the second example, if I had this one, 4.7 liters, 100 kilopascals, 25 degrees Celsius, that's sort of like let's say regular conditions, like a decent day in the summer that's not too hot, but 100 kilopascals is sort of about what we would normally experience day to day. 25 degrees Celsius, that's kind of a warm room, but we'll call it, well, we won't even worry about calling it anything. And then what is the new pressure going to be if I have the gas expand to 20.3 liters and 368 degrees Celsius? Now, I want to point out two things. Number one is that my volume is increasing. Think about what should happen to pressure when the volume is increasing. Also, my temperature is increasing. So maybe kind of a semi-predict what you think is going to happen. Not in terms of a number, but in terms of what do I expect? Do I expect to be more than 100 kilopascals or less than 100 kilopascals? So putting down the information that I have, pressure is the one I'm looking for, doing the temperature conversions right away so that I don't forget, and then taking that information and putting it into the combined gas law. And again, I should have said this in the first one, but strongly encourage you to work this through on your own, not just watch it, but also participate in some way. So taking the numbers that I have, putting them in where they belong, realizing that second pressure is the thing that I'm solving for. And this time I wrote the formula the other way around because I realized that I'd always been putting the ones first, but I always like having the thing I'm looking for also to be on the left. So I just switched the formula around, but that's the only change to it. Again, I have to divide both sides by 20.3 liters to take it off of the left and multiply both sides by 641 Kelvin to get it off of the that side. So let me just say that again to make sure I got it right. Divide both sides by 20.3, multiply both sides by 641. When I do that, everything gets to the other side except for my second pressure, and when I finish that calculation I have a pressure of 49.8 kilopascals. Yes, you could have written that as 50, that would have been okay, but if you were looking at 50 on your calculator, 50, if I wrote down 50 and you were looking at 49.8, you might not have caught it. Again, I don't need units all the way through, but I do need them on the final answer. Okay, there's not a whole lot more to say about the combined gas law. There's not a whole lot more to say about what kind of calculations you're going to be seeing because you've already seen a bunch of gas law types of calculations anyhow. On a test, on a quiz or something like that, oftentimes I would only give you the combined gas law because you can take the combined gas law and get any of those other ones. Just ignore temperature, ignore pressure, ignore volume, and it reduces to one of those other ones. Anyhow, don't forget to change your temperatures, and we will talk to you another time.